So question number 3. So in the circuit shown in the figure, the potentials of B, C, and D are okay. They have given a circuit diagram again. This is a battery of EMF 12 volt, and this is a battery of EMF 6 volts, and the middle point is grounded. It is grounded, so it is connected like this. They have connected a resistor. One more. They have connected. The circuit is connected like this. So the resistance of this is 1 ohm, this is 2 ohm, and this is 3 ohm. The points they have named are, okay, let us see this one. The points they have named are, this is named as point A, this is named as point B, this is named as point C, and this is named as point D. They are asking to find in the circuit shown in the figure the potentials of BCD are. What are the potentials of BCD? So see here. What is the current in the circuit? So the current in the circuit will be E net by R net plus capital R net. Okay. So that what is the E net? If you have observed that 12 and 6 are in series and now they are wrongly connected. So net EMF will be 12 minus 6 by net internal resistance. They have not mentioned any internal resistance for those two cells. Plus the external resistance will be 1, 2, and 3. They are in series, so it will be 6. Clear? 6 ohms. So this will be equals to 1 ampere. So current that will be delivered by this 12 volt battery will be EMF. This will be 1 ampere. And that current flows in all these three resistors which are in series. And if you have observed that the negative terminal of both the cells are grounded, means the potential of the negative terminals of the two cells is 0 volt, whereas the potential difference between the negative terminal of the first cell and the positive terminal of the first cell is 12 volts, means the positive terminal of the first cell is 12 volts. So the potential of A, directly I can write that, because A is directly, point A is directly connected to the 12 volt positive terminal of the 12 volt battery. So the potential of that, what is that, point A is, potential of point A is 12 volts, I can tell that. Now that 1 ampere current flows through this 1 ohm resistor which is connected between A and B. So potential difference between A and B will be equals to the current flowing between those 2 points multiplied with the resistance between those 2 points. So that will be nothing but 1. Clear, isn't it? So VA is 12 minus VB I have to find, that will be equals to 1. So VB will be equals to 11 volt. Clear. Now the same current flows between B and C also. So VB minus VC will be equals to, what is that I can tell? VB minus VC will be equals to the potential difference between the 2 points will be equals to the current flowing between the 2 points multiplied with the resistance between the 2 points. VB is 11 we got now. So minus VC will be equals to 2. VC will be equals to 9. Clear, 9 volt. Then what about the, similarly you can tell that, or else you can directly tell that, because negative terminal of the 6 volt battery is connected to earth, means the potential of it is 0. So the positive potential of the positive terminal of the 6 volt battery will be 6 volt, which is directly connected to D. So the potential of D will be nothing but directly 6 volt. We can tell it. Clear? So this is your question. This is your answer. So then next one, question number 4. See this question number 4. They have taken a circuit again. They have given you a circuit here. This is 3 ohms. This is 2 ohms. This is also 2 ohms. Next one. This is a 9 volt battery. This is 3228884. Okay, this is 8 ohms. This is also 8 ohms. This is also, this is 4 ohms, and these are 2 ohms, 2 ohms, and 2 ohms. The current in the circuit shown in the figure, the current through, okay, they have given what is the current through 3 ohm. Okay, options are the current through 3 ohm resistor is 0.5 ampere, the current through 3 ohm resistor is 0.25 ampere, current through 4 ohm resistor is 0.5 ampere, the current through 4 ohm resistor is 0.25 ampere. So I have to choose one of these options. So check this. So here, see here, if you have observed that these three are in series, the effective of this will be 8 ohm. For this 8 ohm is in parallel. Okay, I will write this. For this 8 ohm, this 8 ohm is in parallel. Uh, this is 8 ohm. These two are in parallel. The effective of this will be 4. Now, if you have observed again, this 2, 2, 4, and 2. These are in series. The effective of this will be again 8. And these two 8s are in parallel. The effective will be 4 ohms. Then 3, 4, 2 are in series. So the effective will be how much? Okay, that will be nothing but 9. So I can tell that this is the effective resistance connected because the battery is 9 ohms, and this is of battery is a potential 9 volts. So the current will be nothing but I is equals to net EMF by net internal resistance plus net external resistance. Net EMF is 9, net internal resistance is not there, external resistance is 9 ohms. This will be 1 ampere. So the 1 ampere current leaves this positive terminal. So I am redrawing it once again. See this one. Uh, See this one. This is the cell. This is um, this is 2 ohms, this is 3 ohms, this is 8 ohms, this is also 8 ohms, this is 2 ohms, this is also 2 ohms. In place of the last three resistors which are in series, I am writing it as 8 ohms. So what is the current that is leaving the positive terminal of the battery? The current that is leaving the positive terminal of the battery is 1 ampere. So this is 1 ampere. So 1 ampere on reaching this point will be divided into how many parts? Two parts. Some will flow into this and some will flow into this. What are those connections? How is it, how it will be divided? See this one. So 8 and 8 are in series. Sorry, 8 and 8 are in parallel. The effective of this will be 4. 4, 2, 2 will be in a series. The effective will be 8. So mm, for this 8, the left side resistance is the right side resistance is nothing but 8 only, so that the current will be equally divided into those two parts. So this will be in this, it will be current will be 0.5 amperes. In this also it will be 0.5 amperes. Clear. The current on reaching this point, 0.5 amperes on reaching this point, it will be divided into how many parts? Two parts it will be divided, because it will be the parallel combination again. So this will be 0.25 amperes and this also will be 0.25 amperes. So then what is the current flowing through the 3 ohm resistor? The current flowing through 3 ohm resistor is nothing but 1 ampere, and the current flowing through the 4 ohm resistor is nothing but 0.25 ampere. So that will be my answer. So current through 4 ohm resistor is current through the 4 ohm resistor is 0.25 ampere. This will be my answer. Okay. So so next one, question number 128. What is question number 128? See this one. They have given a circuit again. This is a 5-volt battery with an internal resistance of 2 ohms. Okay, to this a resistor is connected in this manner. A resistor of resistance 10 ohms. This is a resistor of resistance 10 ohms, and to this a 2-volt battery. This is 2-volt battery with an internal resistance of 1 ohm is connected in this manner. Then they have mentioned that this is P2, this is P1. They are calling it. A battery, a 5-volt battery with internal resistance of 2 ohms and a 2-volt battery with an internal resistance of 1 ohm are connected to a 10 ohm resistor as shown in the figure. The current in the 10 ohm resistor is how much? They are asking. What is the current in the 10 ohm resistor? If you have observed that, I can treat this as the parallel combination of two cells. So see this one, how I am drawing it. This will be, this is the first cell. I am calling it 1 minute. I will redraw this one. You will understand it properly. This is the first cell. This is of EMF 5 volt and internal resistance of this is 2 ohms. Then this is positive terminal. This is the negative terminal. This is of EMF 2 volt and internal resistance 1 ohm. And to this I have connected a resistor of resistance 10 ohms. This is 10 ohms. So this point is named as P2 and this is named as P1. Observe this properly. This is named as P2 and P1. Clear. So then in the 2 ohm, so in the 10 ohm resistor, the current flows from where to where, and what is that value I want to find. So that if you have observed that this will be the parallel combination of cells. When cells are connected in parallel, what is the net EMF in the circuit? It will be, and if you have observed that these cells are wrongly connected in parallel, means that positive of the two cells are not connected on one side and the negatives are not connected on the other side. Positive of the first and negative of the second are connected on one side, negative of the first and positive of the second are connected on the other side. So this will be treated as the wrong connection in parallel. Clear? So then what will be the total current in the circuit? So see this one. I will be equals to net EMF in the circuit by means what is the net EMF? E1 by R1. So whichever has been reversed, take the negative sign for it. So minus E2 by R2 by 1 by R1 plus 1 by R2. This is the net EMF. Net internal resistance will be 1 by 1 by 1 by R1 plus 1 by R2 plus capital R. Clear? So if I have substituted in this, what is E1? 5 by 2 minus 2 by 1 by 1 by 2 plus 1 by 1 by 1 by 1 by 2 plus 1 by 1 plus R is 10. So solve this equation. What is that I have? 5 by 2 minus 2 by 1 means okay 1 by 2 minus by 1 by 2 plus 1 3 by 2 okay by 1 by 3 by 2 means I can write 2 by 3 plus 1. So this will be nothing but, if I have solved this 2 gets cancelled. It will be nothing but 1 by 3 plus, okay, this is 10. 32 by 3. 32 by 3, 3 also gets cancelled. It will be 1 by 32. 1 minute. 1 by 32 means 0.03 amperes. It will be roughly 0.03 amperes. From where to where the current is flowing? See here, the current P2 from P2 to P1. This is what I can tell. So this is what I can tell. The current will be P2 to P1, man. Why did we say that P2 to P1? See here, E1 by R1 is greater than, observe this, E1 by R1 is greater than E2 by R2. Clear? So then that first cell delivers current. It delivers current. Okay, it delivers more current, then that will flow, that excess current will, current will flow through which one? The external resistor. So it flows from P2 to P1. That is what I can write from P2 to P1. From P2 to P1. For example, if it is E2 by R2 is greater than E1 by R1, then we can say that it flows from P1 to P2. But in our question, it will be from P2 to P1. Okay. So this is your answer. Next one, one more. Question number 2. From exercise 2, question number 2, man. Exercise 2, question number 2. See this one. They have given, okay, I will draw this one. This is this, okay. They have given n number of cells that are connected in series. Okay, on this cell, this is the cell. Okay. This is cell 1. This is cell 2. This is cell 3. Like this, n number of cells are connected. Cell 4, like this. So many cells are connected, and this is cell n. Like this, so many cells are connected in this region. Okay. Now, see this question. A group of n cells where EMF E varies directly with the internal resistance as the equation. EMF of these cells is varying with internal resistance as the equation. En is equals to 1.5 Rn. Clear, are connected as shown in the figure. The current in the circuit is, what is the current in the circuit they are asking to find? So let it be I. What is the current in the circuit? So I will be equals to, if you have observed that the current in all the cells will be the same, and we can treat it as the series combination of cells. In series combination, what is the expression? Or in any combination, E net by R net plus capital R net. Clear? What is E net here? E net will be E1 plus E2 plus, and all are correctly connected in series. So it will be En by R net will be R1 plus R2 plus and so on Rn. plus external resistance. There is no external resistance in the circuit, so it is 0. I am taking it. So what is E1? E1, according to this equation they have given, I can write it as 1.5 R1 plus 1.5 R2 and so on, 1.5 Rn. I can write that. Clear. By internal resistance it will be R1 plus R2 plus and so on Rn. I can write that. Clear. So if I have taken 1.5 as common from the numerator, it will be R1 plus R2 and so on Rn. In the denominator also I will be having the same, it will be R1 plus R2 and so on Rn. Clear. And this ratio will be equals to how much? 1.5. So this is the current in the circuit. So current in the circuit will be equals to 1.5 amperes. Clear. So then